Okay, good morning or good afternoon, everyone. Welcome again to APNIC e-learning web class. Today is Wednesday, the 7th of October in 2015, and from Brisbane in Australia, it's already 3 o'clock in the afternoon. So for the next hour, we will be talking about the main topic that we will be covering is about DNSSEC. So this is the third session out of basically three that we do almost every Wednesday. So it's like 1 hour e-learning sessions that's provided for free to members of the internet community. Now, before we begin with that, I'd like to just introduce myself. My name is Cheryl Hermoso. Some of you who have attended the other sessions probably already know me. I work as a training officer for APNIC, and I do conduct workshops, e-learning for members of the internet community on topics such as network security, IPv6, BGP, routing, DNS and DNSSEC, and internet resource management. Now, we do also offer, aside from face-to-face workshops, we offer this e-learning session for free so that we can reach more people. So just as a reminder though, that after the 1 hour session, I will be asking you to fill in a short survey for me. Okay, so I'll post the link there. The link should also be on the slides towards the end. So if you just take a couple of minutes to fill that in, that will be really helpful for us to know whether there are things that we can improve with our e-learning program. All right, so with that, let's begin with our topic, which is DNS Security Extensions. I'm not sure if most of you that are in this class have attended the previous session. So in that previous session, we pretty much discussed about the DNS hierarchy. And the goal of that is to find out where the possible vulnerabilities are when you talk about DNS. DNS is a distributed system. You have different servers that are practically located everywhere around the world. And then there's a way to cohesively communicate them. If you need answer on a particular domain, it doesn't have to say just come from a single server. It's usually from a server that's authoritative, which may be halfway across the globe. So we have these different machines. You have your resolvers, which is your operating system, your machines, laptops. You also have recursive or caching name servers. And then you have your authoritative name servers, masters and slaves. Okay, primaries or secondaries. And then in there, you have your zone files. You can do dynamic updates. You can add, remove, edit different resource records. Resource records are basically entries in your zone file. It's the mapping from one domain or one resource to another resource. So we've looked at that hierarchy in the previous session, and we tried to identify where are the possible problems, where are the issues, where are the possible vulnerabilities, weaknesses, and loopholes. And we said that there are two main ways, or yeah, two main parts of the DNS system that can be abused. One is the way that these servers are communicating with each other. So we need to provide some sort of server protection. The other one is with the actual data or the resource record itself. How do we know? How do we verify that it is correct and that this information is actually coming from the right source? Is it coming from a malicious user, or is it coming from the authoritative name server? Obviously, it should be coming from your authoritative name server, but once you have that information, once you have that record, how sure are we that it is correct? And the way that we can verify that, we can check that, okay, is by using signatures, by doing what we call as an integrity check. From our end, based on those signatures, we can verify that it actually came from the right source. And so that is the main purpose of DNSSEC. DNSSEC stands for DNS Security Extensions. And so when you look at this diagram here, what are we trying to protect when you talk about DNSSEC? It's the data. Okay, we're protecting ourselves against attacks such as cache impersonation and cache pollution, basically because we can check whether this data that we acquired from the DNS server is actually correct or it was wrong, it was spoofed, or things like that. Right, so here in this session, we will try as much as we can to explain and understand the processes involved, to implement DNSSEC. But before that, let's take a few slides here to discuss about the concept itself. We know what we're trying to protect against, right? Basically, we want to have a way of checking or verify the integrity of the information or the resource record that we obtained. But how do we actually do that? So that's where DNSSEC would come in. DNSSEC stands for DNS Security Extensions. And its main goal is essentially, as we've said, it protects the integrity of the data in your DNS by doing a few things. One of that is establishing a chain of trust. So we probably know, coming into this session, you probably know that there is a DNS hierarchy tree, root, top level domains, and then followed by a chain of different nodes, different domains that falls under those TLDs. And so we can verify that the data actually came from the right source or actual authoritative name server by establishing that chain of trust. You do a recursive query from the root top level domain going down until you reach the authoritative name server. So through that, you can have some form of chain of trust. And if that trust is somehow violated, then there is reason to doubt whether the information that you got is actually correct or not, right? Another way of doing it is to use DNSSEC to provide digital signing. So it's a way of digitally signing the data to attest its validity. So like in emails, right? If you want to send an email with a digital signature, what do you do? Okay, you use cryptography. Okay, you use your private key to sign your message, your email, and then send it across. Once it is received by the other side, by the destination, they will check whether this actually came from you. How? By using your public key. Okay, so you have two key pair, a private key and a public key. And that is what we call as public key cryptography or asymmetric key cryptography. By that, you will have two sets of keys, one private and one public. If you want integrity check, you will use the private key to sign, okay, your message, and when it is received on the other end by the recipient, they will verify using your public key. So I hope the concept of public key cryptography is clear with everyone, because with DNSSEC, we will rely heavily on this concept. We will be using public and private key pair to sign DNS data, DNS resource records, and then once you do a query, your client or your DNS resolver would know or would be able to verify that your signed data is actually correct using public key. Okay, and in detail, we will go through some stuff in the next few slides that looks into this in detail. So what do we achieve with DNSSEC? Essentially, it's authenticity and integrity of data, plus, okay, you're establishing a trust, okay, going to third parties from the parent zone using the chain of trust. If you want to know more about DNSSEC, the RFCs that covers that are the following. You can see it down there. RFC 4033, 4034, 4035, and there's a few others. Basically discusses each and every aspect of DNSSEC from the new resource records up to the cryptographic algorithms that are supported by the DNSSEC implementation. All right, so we know by this point what DNSSEC can do for you, and in general, what technology we're going to use for this. So we know that we are going to use public key cryptography, right? But how exactly will we do that? Okay, you know it's signing, you know you're going to sign some data, but which data exactly? So I guess by looking at this slide, some of you have seen this in the previous session, this will give you a broad background or broad idea of the stuff or the steps taken to implement DNSSEC. First of all, you have records. What are records? Resource records. Those are your mapping. In your zone file, you'll have resource record. You have A record if it's domain to IP address, quad A records if it's IPv6, NS record if it's about DNS settings, okay, the authoritative name server. You also have CNAME, which is an alias. What else? They also have pointer records, which is for your reverse DNS. You can also have MX record, which is for mail exchange. So those are the common types of resource records. Okay, so those are mappings, one resource to another resource, usually a domain to IP address. So you find that in a text file called a zone file, or sometimes in a database. So essentially in DNSSEC, what you're doing is you're signing each of those records. So say you have an A record followed by a C name followed by an MX record. You are signing each of those records, okay, and then providing a signature to the public. When you do a simple query, what happens? I'll do a dig, or maybe I'll go to my browser and type in a domain name. What happens is that my resolver will go to a recursive server and will do a query to find out the answer. The reply will be, say, an A record and then given to me, right? So aside from that information, I should also get a signature, okay, a signature of that record because I signed it. So record is signed, we use private key to do this. Next one, the signature of that record will also be published by using, basically it's using your DNS data. So you have two things. Now you have your original record, your original resource record, then you'll also have a signature of that resource record. Does that make sense? So you sign your resource record with a private key, and then the output will be the generated signature. Now both of this information should be published. What else do you need? So given our scenario, in the mail scenario, right? At the end, when it is received, you should be a way to verify that. And we will use public key to do that, right? So public key of my public and private key pair that I generated will also, or should also, be published. That's the third one there. Public key is also published so that the signature of my record can then be verified later on. So that's the first part. You have a signature of your key that is verifiable. That's pretty much what it is. And the next one is like the association between the parent zones and the child zones. The parent zone will sign all of these records. The child zone will also sign all of these records separately. So whichever zone I'm authoritative, I will have to sign it. If I've delegated some part of that to my child zones, then they will have to sign that particular part. It's no longer my responsibility. It has already been delegated. Okay? Now, once you have pretty much done that, okay, we want to establish a chain of trust. So that's the second part of what you want to achieve with DNSSEC, right? So parents will now sign the hash of the child zone. So I want you to understand this concept, okay, so that it's easy for you to see the ways that we implement this. This is what we want to achieve. Okay, we want it signed, we want to have hash, we want those hashes signed by the parents and all that. But how are we now going to use DNSSEC implement DNSSEC to do this? Okay, two main things. Now, when you talk about DNSSEC, there are two parts in which you implement this. Okay, so depending on what you do or where you are in the chain, you'll have to do two separate or different things. One is, of course, if you have a domain. So you have a domain, your company has a domain, you're an enterprise network, and you're maintaining your company's domain, right? So if you are an authoritative server, you have your own domain, then it is highly encouraged that you sign your own zone. Okay? If you have a domain, either it's forward domains or reverse domains, same thing, you have to sign your zones. Why do you want to do that? For obvious reasons. You want to have a signature of your signed zones so that it can be verified that it's true. Okay? And then you should be able to answer queries, not just for the record itself, but also provide the signature alongside that query. Okay, so one thing, if you have a domain, if you're maintaining a domain, if you're a zone administrator, you have an authoritative server, then please go ahead and sign your zones. Okay, sign your domains. Now the other part of this is, like, that part is from the server. Server provides that information so that it is verifiable. Now the other part, the other end of this is with the resolvers. What are resolvers? Those are the ones that check or connect with the authoritative name servers to get answers. Okay, they send the query. So for these resolvers, they should act as validating resolvers, meaning they should check whether the signature that they got and the data that they got is actually verifiable. Okay, so basically here you're validating the responses that you got from the authoritative name server. There are two things that can happen there. One is, if the domain that you asked for, the authoritative server, does not support DNSSEC yet. So it functions as usual. You get the record that you wanted, give it to you, but no DNSSEC involved. Now, if the authoritative server is using DNSSEC, it's enabled to do DNSSEC and it answers DNSSEC queries. And then you have this validating resolver that does the query. My question here now is not just for the record itself, but also for the signature of that record. Okay, so then I receive that. I receive two, a record maybe, and then the signature of that record. Then I will then authenticate the responses. I will check whether it's correct. How? By looking back into this. Okay, the public key is also published. So I'll also get the public key from the authoritative name server so that I can then verify. So I have three things now. The original data, I have the signature of that data, I have the public key. By using that public key and the signature, I can verify that they are the same, that they are correct. Okay, so just remember, in this case, if you are maybe you are a service provider or an enterprise network, and you're providing a DNS server for your clients, for your customers, for your staff to be used as a recursive server, meaning in their configuration, in their IP configuration, it is set to use your DNS server to do that recursion. Now you have to do validation. You have to enable your resolver to do validation. Okay, even if you don't have a domain, then that's fine. You're acting as a validating resolver. Now, if you have a domain, then you have to implement DNSSEC, okay, and sign your zones, sign your domains. Does that make sense, everyone? I hope that clarifies some things here, okay, because it should be both ways. You have a DNSSEC enabled server that answers DNSSEC questions. You also have a resolver that verifies the answer that they got from the authoritative server. Okay, any questions on that front? If not, so you should understand the concept at this point. Now, what's new with DNSSEC? We always say that it probably takes a while for people to get a grasp of the whole DNSSEC idea. It's because we are familiar with DNS system, but we actually introduced a lot of new concepts in DNSSEC. So first of all, we will have a new resource record. Okay, we will be introducing new resource records. Next, okay, which I've told you about earlier, you have a chain of trusts. Okay, DNS servers are not isolated in themselves. It follows a chain. It follows a chain from the root going to that authoritative name server, and you want to establish that chain. Okay, the third concept that we will be looking at is key generation and signing. We said that you should have public and private key. Okay, how do you generate those keys? How do you change those keys? And the last one there is, as discussed in the previous slide, validation. How do you do or implement validation? Okay, so let's go on with the first one, new resource records. Okay, we are introducing new resource records. Previously, you should be familiar with the different types of resource records, Quad A, NS records, SOA records, MX records, CNAME. Those are the records that are mostly used. Okay, if you're just doing DNS, the one that you will query is probably one of those resource record types. Now, here, based on RFC 4034, we are actually introducing 4 different resource record types. Okay? And this is based on the concept that we have discussed earlier. Now, let's look at them one by one. The first one over there is RRSig. RRSig is a signature. Okay? It's a signature over RR sets made using private key. So if you go back to the slide, the very first slide that I want you to understand, we said that you will have your record, it will be signed, and that signature will be published. That signature is published using this resource record type. Okay, that is the signature of your resource record. Now, one thing to understand here is we don't sign each of the resource records by themselves. They should be over an RR set. When you say RR set, it's a group of resource records. So let's say, for example, in your zone file on the very top, you have your SOA record, followed by NS record. Maybe you have 1 or 2 NS records, followed by, say, 3 or 4 A records. So you're grouping your resource records inside the zone file based on the type. So SOA record on top, just 1. Okay, group that, it's just 1. You have followed 2 NS records, so group those 2 NS records. Next, you have 3 or 4 A records, group them together. And then you sign based on those groupings. That's what we mean here. You are signing the set, all A records in 1, all NS records, 1 signature, all SOA record, maybe because you just have 1, then just 1 signature. So you're signing an RR set and not individual resource records by themselves. Unless, of course, you cannot group them with anyone. Okay, I might have that somewhere here, but let's just understand the records first, right? So you know what a signature is, RRSig. Next one, we said that you should publish the public key. So that's it. DNS key resource record will hold a copy, okay, of your public key. This is now also available to the public because your DNS data can be checked to find out the DNS key for that. All right? Next one, you'll have a DS record. Now, we've been talking about chain of trust. Now, when you sign your zones, okay, a delegation signer, a DS record, will also automatically be created. This DS record is a fingerprint of your public key. So you don't have to like push the entire public key going up to your parent, but you'll have a smaller, maybe, yeah, a shorter version of that public key. Okay, that shorter version is a hash or a fingerprint of your public key. That will then be sent to your parent zone so that you can establish that chain of trust. The parent zone will sign your public key. Does that make sense? Okay, well, let's look at some example of this in the next few slides. And then the last resource record there is your NSEC. Or if you're not familiar, NSEC actually, it's not secure anymore, so they have a new one called NSEC 3. So what is this? It's NIC secure. Now, if you have, say, as an example, if you have resource records there, say you have web, HTTP, mail, and then all of those records there, but if someone asks for a record that is not there, maybe I asked for ftp.apnic.net, but apparently there's no such thing, not in the resource records. And then someone, a malicious user, decided to give an answer that is wrong. Now there is still a way for you to verify that I didn't get this from the correct source. Okay? And we do that using the NSEC or NSEC 3 record. It indicates which ones follows which resource records. So it's kind of like inside your zone file, you have a chain. So you have NS record, followed by A record, followed by SOA record, followed by MX record. So you are enumerating the resource records that are following each other. By doing that, okay, if something is not there, okay, you verify their non-existence by enumerating what are the resource records that are in there. Okay, so I hope you understand that. Those are the 4 new resource records, and by looking at them, by understanding them, you have an idea now of how all these things work. Okay, so just to summarize that one from the previous slide, so you'll have RR sets, resource record sets. These RR sets are signed using the private key to prove authenticity. Okay, this signature, okay, of the RR set are also published in DNS, and it is done using the RR-SIG resource record. Okay, and then you also need to publish the public key. So you use DNS key to publish the public key so that later on you can verify the signature of the data, your RSA. Okay, and then you have DS record, which is when your parent signs the child zone's record to prove the chain of trust and that identity. Okay, let's look quickly at each of those resource records. I hope at this point you already know what it is, what they are, and know what their function is in DNSSEC. But here I wanted to show you examples of each key. So we said DNS key is the resource record type that contains your public key. So it looks like this. So the one here at the bottom, see this set of characters there, that is your signature. That's your public signature, or public key, sorry, that is in base 64 format. So there are a few other things that you can find there. That one, 256, is a 16-bit flag. Now, it's 256 if it's ZSK, it's 257 if it's KSK. So I'll explain about the ZSK and KSK in a little bit, but just remember that depends on which one, ZSK or KSK, the value there actually changes. What other fields do we have? This one is your protocol octet, and this one is the DNS key algorithm number. Which algorithm did you use to create that public key? And then this last one there is your actual public key. It's shorter because it's in a different format. It uses base 64. Okay? So in DNS key, it also gives you some timing parameters, some timing data. So at the end, you know when you created this key, when is it published, and when it will be activated. When you generated this and you didn't do anything, by default, it will use the same creation, publish, and activation date. But as you will see later on, when you start doing or you get familiar with DNSSEC, you'll know that you will have to generate keys once in a while or on a regular basis. And so you can actually create your keys much sooner than when it's published or activated. So you can have different values or timing parameters for the create, publish, and activate. Okay, and that means like if you want to create it now, but you don't want to publish or activate it yet, you can do so. Okay, and DNS key is quite good there because it gives you the timing parameter, so you're not confused. You know when exactly is your key valid or not. Okay, next one here is your RR-SIG. Again, RR-SIG is the signature over an RR set. So in this case, I have 2 NS records. And then I have 1 signature, right? So only 1 signature for both NS records. But I have some indication. This one here is your RR type that is signed. So meaning that this signature signed an NS record. The next one there, 5, is the algorithm used to do this digital signing. And this one there, the 2, is actually the number of labels that are signed. So remember, we had 2 NS records that we signed. So in your RR-SIG, okay, you know that it signed an RR set consisting of 2 resource records. And then here, you'll find your actual signature. There is a signature expiry and the time or date when it was signed, okay, because those signatures expire. Your public and private key does not expire, okay, although it's good to change it once in a while, but the signatures expire. That's why another very important concept in DNSSEC that you'll have to understand later on is your key rollover, okay, and signing. So you sign once, it's not valid forever. You have to re-sign it again every so often. If you see here, it's valid for 1 month. Okay, I signed it in November of 2012, and then I have to, this will expire in December of 2012, so I have to re-sign it again. Okay, signing and key rollover are very important concepts in DNSSEC. Now, another record is your NIC secure. I've already explained this quite a little bit earlier. It's basically chain of authoritative owner that is inside your zone. Okay, so you'll have a listing of all the zones that are there, and by listing down what should be there, we're essentially proving the non-existence of a domain. So this is an example. This is an NSEC record, myzone.net, NSEC, and then blog.myzone.net. If you notice somewhere here, you have ANS, SOA, MX, RRSIG, NSEC, and DNS key. Those are your RR types that are following this particular resource record. So because you've enumerated the ones that are there, you'll know which ones should not be there. So another example of our NSEC record that you'll see there, for mailbox, you notice here, it's followed by A, NSEC, RSIG, and same with www, you have it there. All right? Okay, now the last of these resource record types, we have your DS. DS stands for Delegation Signer. So delegation is done using from parent to child, right? So from the child will have to send a copy of that DS record to the parent. That parent will add that in his zone file and sign the entire zone file. Okay, that's how you establish a chain of trust. So this one here is your DS record. Okay, notice we have two. So different algorithms are used for this one. And typically, that value there, 1 or 2 in this case, is the digest type. So we usually publish both because some older DNS servers don't understand or don't have support for SHA-256, only SHA-1. So we will have to use both. So this is what you do, right? So, okay, you sign your zone. Once you have signed your zone, you'll have a DS record. Now you go to your parent zone and then give them your DS records. And then it's the turn of your parent to sign the entire zone. Okay, that's how you establish the chain of trust in this example. So let's just say we have APNIC.net, and then training.apnic.net has been delegated to me. So I have a domain. I have training.apnic.net. Now I want to sign it. So I went ahead, follow the steps. We'll go through the steps later, but I'll follow the steps to sign my zone. Once I've signed it, I will have a DS record. That DS record I have to give to my parent zone, which in this case is apnic.net. Okay, and then apnic.net will have that pointer to us because they signed our public key. All right, so that's exactly what I'm talking about, chain of trust there. It establishes a chain of trust from the parent to the zone. The parent does not exactly sign the child zone, but the DS record. The pointer to the child zone is your DS record. And when you sign everything from the root, this means that your root is basically the top of the chain of trust. Okay, any questions so far? So you know the different resource record types, you know what their function are, you understand how DNSSEC works, what's the concept behind it. Now, what happens if I sign my zone now, and then after a couple of days, I have to add a new entry. So that means I have to sign again, right? You have to re-sign every time you add something, edit something, remove something in your zone file. Either that, or when it's about to expire, I also have to re-sign it. Okay, so it's very administrative heavy. You have to do a lot of tasks when you implement DNSSEC. So every time you make changes, you have to sign it. Once you have signed it, you will have a new DS record. When you have a DS record, what happens? You will have to go to your parent zone and give them your new DS records. So you see how it can be heavy administrative-wise. So what we do in practice is instead of using one key or one key pair, okay, we will use 2 key pairs. Okay, so that you avoid that fact that you have to resend everything to the parent zone every time you make changes. So we will use two key pairs. One of that will be used to actually sign your zones. So whenever you make changes, you sign it, you use that key pair. But then there is another key pair that will only be used to sign your zone signing key. So in that sense, your DS record doesn't change every time. It will still keep the old one, and you don't have to come to your parent every time. So that's how you do it. But that is an operational choice. If you look at the RFC for this, it actually allows you to use a single key or both keys. It's all up to you. It's an operational choice. But what we normally see is people would definitely go for two keys. One is for signing the actual zones. The other is for signing the zone signing key. So when I talked about ZSK and KSK earlier, it's about that. You have two sets of keys. One is zone signing key or ZSK. The other is your key signing key or KSK. Zone signing key is what you use to sign your zones. Okay, it's usually signed by the KSK. Okay, a KSK signs the ZSK and it points to the parent zone. So basically, your key signing key will be available longer than the zone signing key. If your zone signing key, you change it, let's say every month. Your key signing key, you change it every year, so you don't always bother your upstreams or your parent zones. So what does that mean exactly? So there is such a thing as signature expiration, right? We talked about that. The signatures has a validity point. Usually that validity is set to 30 days. Okay, you can see that in the metadata. You can also see that in the actual record itself, right? The expiry and the date creation is there. Keys do not expire, but signatures do expire. So when the signatures are about to expire, you have to re-sign it. Okay, now again, with a key, you don't have to change it, but it's always good practice because you're exposing the key out there. You have to sign the you have to generate new key after a while. So what you normally do is for ZSK, you have smaller key length, but you change it more often. With KSK, you have longer key length, but you don't change it as often. Maybe you only change it every year or maybe every couple of years. But you should have a and maybe a rule when you want to do those changes. How often do you want to change your ZSK? How often do you want to change your KSK? And then obviously every 30 days, or you can change that value, you have to re-sign your zone files because the signature will expire. Okay, so that's the next step for you. Once you already know how to implement this, okay, you don't just jump in and implement and then leave it after that, because again, it will expire after just 1 month. So there is continuous tasks for you to do to re-sign those zones and to generate a new key pair. Now, question is how do you now have that chain of trust? Not all the parent zones has support for this. The good news is when you talk about the top level domains, CCTLDs, there have been good support, okay, over the past years of improving the situation and signing most of the TLDs. So you might have to check, hang on, I'm using, say, APNIC.net.au. That's just an example. There's no .net.au, but this is an example. You're using APNIC.net.au. That means that .au should be signed, right? So you kind of rely on the TLDs, the root servers, and everything on top of you to be signed before you sign yourself. Okay, there is a workaround for that. You can use third-party trust anchors if you want to implement DNSSEC without your parents signing their zones yet. But the ideal way is to have your parents sign it. Okay, so good news here is, although not every CCTLD has DNSSEC support yet, but it is improving right now. Okay, so now how do we implement this? First of all, let's look at both parts, right? First, your resolver. Resolver does validation. It does the query for you, right? Those are your recursive servers. So what you do is just enable DNSSEC validation and set it to yes. This command, by the way, is for bind. So enable DNSSEC validation. And what happens there is when I receive the answers to my query, it has the resource record that I asked, maybe a record, it has a signature, it has the DNS key. So a record, RRSig, DNS key. Using all those three, I'll be able to check, I'll be able to verify. Is this actually the signature? Okay, is this a correct signature? If yes, then I will have something called AD bit or authenticated data. That's a new flag that shows up if the record that I checked is actually validated, meaning it's correct. It's signed, it's coming from the right source. I should trust this data that I got. That's what happens in the resolver. So it's kind of very simple for you to do, but just make sure that you understand the concept behind it, because once you do this, okay, and you have customers that cannot access certain websites, one possible reason is because it's not DNSSEC validated. So if it's not validated, I will not forward the answer to my client. So they're left wondering why they cannot access that site, and it's possible that it's because it's not DNSSEC validated. That's how you protect your clients. So, but just make sure that you understand that so that you can explain very well to the client what was the issue, why they cannot access that website or that domain. All right? So, there's a lot of DNSSEC resolvers out there, open resolvers, and most of them are already doing DNSSEC validation. So if you're not doing this yet and you want to give it a try, just use Google's public DNS or DNSORG's public DNS, and you should see that. You can do a simple dig at 8.8.8.8 for some domains, and if it's validated, you should see an 80-bit if these domains are actually using DNSSEC. All right. If you want to have something more visual, a tool that you can use on your machines, there are add-ons that you can include or install on your web browsers. One of that is this one, DNSSEC Validator, which gives you an indication, green or red, whether it's DNSSEC validated or not. Online, there are also web tools such as these two. You can have a look at that and explore, and then look at some of the zones that are actually DNSSEC validated. All right, so any questions with validation? I hope the concept and how it's implemented is clear with everyone. Now, the other part of this is setting up DNSSEC, signing your zones if you're the authoritative server. Okay, if you have a domain, you're the authoritative server, you have to sign your zone. Now, how do you go about that? So these are the steps that are involved. It's quite simple if you look at it, but again, you have to worry about re-signing and key rollover later on. But initially, you have to do something like this. First of all, enable DNSSEC. So that's DNSSEC enable set to yes, and then DNSSEC validation set to yes. By default, this is already yes, meaning you have DNSSEC as part of your configuration by default. But just so you're aware visually that you're actually doing DNSSEC, it's always good to add this in your configuration. Okay, next step is for you to generate your key pair, your public and private key. Now with DNSBind, there's a utility that comes with it. It's called DNSSEC keygen. So this is a basic command that you do. DNSSEC keygen -a, what type of algorithm you're using. By default, it's using RSA and using the hashing algorithm SHA-1. And then the number or the size of the bits is 1024. And then you provide the name of your zone. Now, depending on whether you're doing KSK or ZSK, you will want to think of the number of bits. Usually by default, ZSK uses 1024 bits. KSK is longer, 2048 bits. Why? Because you're exposing the KSK for a much longer time out there on the internet as compared with your ZSK. Okay, so you can set it to higher, maybe 2048 and 4096. It's all up to you. Next, after you've generated your key pair, what do? You now have a public key. You have to publish that public key, right? So whatever is generated, you add it into your zone file before you sign it. And then you go ahead with the signing process. And once you have signed it, you will have another file with the .signed in its file name. And that signed zone file does not just include your original resource records inside that zone file. It's kind of modified. The difference is in your new zone file, you now have signatures of your resource records. Okay, so once you have undergone the signing process, if you check the contents of your zone file, you will have now .rrsig record, DNS key records. There will also be a DS record generated, okay, because of the process of signing. And then what you do next is to point to that new signed zone file, okay, instead of your old one, so that now you have DNSSEC. Okay, so this is like the process in more detail. First of all, okay, after you've done DNSSEC enable, next step is to create your key pair. This is the command, you've seen that, DNSSEC keygen, and then which algorithm, the number of bits. And then if you're doing KSK, you add something called -f KSK, but all the rest of the commands should be the same. So after you've done this, you generated ZSK, which gives you two keys, right? Two files, one public and one private. And then when you do KSK, it's the same thing. You generated two files, one public and one private. So altogether, it generates 4 files. Okay, one public and private key pair for each of the KSK and ZSK. Okay, so after you've done that, so that's the main command, the easy way to write that command. And then once you have those file, you have to publish the public key. Like the ones that you've generated 4 files, one of that is .private and then .key. You need the .key, that's your public key. So you include that in your zone file. Okay, so you open up your zone file and then include that using this directive. Okay, you're basically pointing to that file. And then once you've done that, you can proceed with the signing. Signing uses a utility that comes with DNSBind, which is DNSSEC sign zone. So you're signing the zone, you specify which zone, and then you provide the KSK and the ZSK. This is an example command that you can follow. And as I've said, once you have finished with it, once you have signed it, you will generate a file. If you don't specify the -f here, which you can actually eliminate that, you will have a file using your old file name plus .sign. There will be a .signed extension into it. So what you can do next is verify. You can check the file size. You will notice the .sign is much bigger than your original zone file. And as I've said, you will have all those additional resource records inside your zone file. Okay, and then you open up your named.conf like this, and then point to the new zone file, which is your db.myzone.net.sign. So you just replace the old one and point to the new signed zone to do this. All right, so those are the basic steps. I know if you're just like watching right now, it might be not really difficult, but it actually looks quite easy, but it's best for you to practice. So I would encourage you that after you've done this session, try and install DNS. Try and do some signing. It obviously shouldn't be introduction, just some test server. You can just have a dummy domain and then follow the steps that we have shown here. The last step here is, of course, to do some testing. Make sure that it is correct before you make it into production. How? The simple command, there's a utility called dig, right? Dig at your name server for particular domains. So you use the domains that you have signed or anything out there that it's actually using DNSSEC. And then you provide the option plus DNSSEC so that you get the signature together with the zone file. Because if you don't do that, even if your domain is signed, it will only get the resource record, not the signature that accompanies that resource record. Okay, so this is an example. You're probably doing this. I done dig at localhost for this domain plus DNSSEC plus multiline. The plus multiline there is just so formatting wise it looks better. Okay, you can easily understand and see what's in the output. But the essential option is plus DNSSEC. So what do you notice? So I did that command and I have this output. So in my answer section, I have an A record for the domain that I asked, www.irashai.net, right? And then there is a corresponding RRSIG for that. Okay, so www.irashai.net in RRSIG, and then this is my signature. Okay, if this is giving me extra information such as who is the authority for this, which name servers, okay, and then for that record it also gives me the corresponding signature. Basically, for every record that it gives me, okay, this one you have your answer, your authority, and any additional section there. There is always a corresponding signature for that. That's because I asked for DNSSEC. If you're doing DNSSEC validation by default on your resolvers, okay, by default you should see this answer. Plus, somewhere on your flag bits here, you'll have an AD bit or authenticated data. Okay, so I hope that you understand those steps, but that's not all. We've talked about chain of trust. So the next step for you is to push the DS records to your parent zone. So it's on another file. Once you've done the signing, there will be a DS set something record. That's a file. If you open that up, that is your DS record. So you contact your parent zone and give them that. Usually, if say it's a hosting provider like this, they will provide you with a form where you can attach or you can paste your DS record, something like this form. Okay, so you open up your account, you go to that form and fill it in. And then either automatically or manually, they will add that to their machines, to their servers, and then sign it. Another one, which is not here, is if for reverse DNS, right? So you have your IP addresses. You also want to sign your reverse DNS. Now you can do this from the from my APNIC for your domain object in the WHOIS database. You can add 2 fields for your DS record. You can always do that. So if you are going to sign your zones, either forward or reverse zones, okay, you do all the steps that are in here, and then at the very end, make sure that the DS record is updated and pushed to the parent zone. All right, so do we have any questions? So is DNSSEC clear with all of you now? Do you understand? All right, I don't see any activity in the session, but if you do have questions, please feel free to type them in. Meanwhile, the link to the survey is this one. It's also clickable on the slides, but just in case you can't do that, I've also posted that on the chat. Another one is the link to the FTP where you can download your slides. So it's this one over here. You can have a PDF copy of all the presentations that we have done for the day. So any other questions? Any comments from the class? I can see some people typing, so I'll just wait a little bit. I'm not sure what's it about, but like again, if you have questions, please try and write them down here. I'll try my very best to answer them. Okay, if there is nothing, APNIC training implement on Bind 10. Bind 10 is no longer being supported by